So I know last video was a lot of setup, and if you haven't seen it, make sure to watch the previous video on setting up our little plot right here. But in this video, we will finally get to placing some objects, which is very exciting, very cool. This concept here is very similar to another video I made pretty recently on a Minecraft style placement system, and this is like very similar to that first video. So check that out if you want some more supplemental content on this idea. But in this video, we're going to be covering the client side rendering of the preview, like here you can see right here, and the actual server side placement of the object. But no validation. That will be a future video. You can place stuff anywhere. So I hope you enjoy this video, and without further ado, let's get started. So let's get started with actually rendering our objects and placing them. So I have a little sample table in front of me, not too pretty, just a table that we can use to place. It's a bunch of parts in a model. So I'm going to make sure all of these parts are anchored because this placement system is going to be primarily based on anchored objects. And then I'm going to make sure the primary part is set to a part that I want to make primary. So like this one here, if I can like deselect it. Yeah, so this part over here, I don't know why I can't select anything. Huh. Interesting. Did I lock it? Not locked. But yeah. So there we go. Okay. So I just messed up my tools. So we need to make sure that our pivot is actually on the ground level of where we want to place our object. So I'm going to do edit pivot and I'm going to move it down there. So this pivot is going to be at the bottom center of our part because that's how we're going to like render it and place it in the world. So before shoving this away into replicated storage, so we want to create a selection box here and just double check everything works. Set the adorny to the thing. Okay, so this is our selection box because when we like render the preview for the player to place the block to see where like so they give them an outline of where it's going to go, we want this box just for, aesthetic purposes. So this looks good enough for me. I'm going to set the adorny to nothing and we're going to rename this to just we can leave it selection box. I guess it's like box outline. I'm going to rename it to like box outline, I guess. And then I'm going to shove this into replicated storage. And then everything is prepped nicely on this, I believe. Let's move this also into replicated storage. Okay, cool. So we have our stuff in replicated storage. Let's go to client placer now and get rid of this print statement that we made last video. And we need to create a new function, client placer, colon, initiate render preview. And this function will actually run to other functions. Say client placer prepare preview model, which will take in a model, which is a model. So we're gonna run this here. And the prepare preview model will just take the model that we'll figure out later. But this preview model will take the model we actually want to set up. And what we're gonna do is first of all, up here in the set meta table, we're gonna say preview equals nil. So preview will be the model in which we want to like display. So the player is gonna have their mouse, and the mouse, like when they turn on their build tool, they're gonna see the outline, like kind of ghostly image of where the part would be if they were to actually place it in the world. That's what the preview is gonna be because it actually has to be a real model. You can't just like render some ghosts on top of there. So, but it's only gonna be rendered locally, so it shouldn't affect other players. So we're gonna say in our prepare preview model, I'm gonna say if self.preview, then self.preview destroy. This won't be of much use right now, but when we start switching, like cycling between different objects, this will prove handy. So we want to say self.preview equals model clone, and then we're gonna say local box. This will be our box outline that we got. So we're gonna say appear local replicated storage equals game get service replicated storage, and then we'll say local box outline template equals replicated storage dot box outline. Scroll down here, say box local box outline will be equal to box outline template clone. And I'm going to say box dot or box outline dot adorny, not template, box outline dot adorny will be equal to the self dot preview. So it'll kind of mount itself to the model, which should be pretty good. And we're gonna say box dot parent equals self dot preview. So it'll show up on the model. It'll be kind of with the model and get destroyed with the model when the model gets destroyed. So now we need to give the model, like we have the outline. Now we need to give it that like kind of ghostly look. So we're gonna iterate through. So for underscore part in self dot preview, get descendants do. So we're gonna iterate through all of the descendants of our preview, but we need to verify that they're parts because models can have other things. So we're gonna say if part is a base part. So if it's a base part, then we know we can set the part.canCollide equal to false. And then we're gonna, just to be safe, we're gonna set part.canQuery equal to false as well. And we're gonna say part.transparency equals 0.5. So depending on your model, depending on your models, you might have to adjust this. But for my case, like in case you have invisible parts, this will actually make them visible, might make things look weird. But in my case, all of this works out fine. So this will kind of give the part like a little ghostly feel. And at the bottom, all we have to do is say self.preview.parent will be equal to the workspace. There we go. Cool, cool, cool. So now let's just get our table. And actually, first of all, I'm going to move the table into a folder in replicated storage, and we're going to call this placeable objects. And we're going to shove the table into there. And then in our client placer, we're going to say local placeable objects will be equal to, okay, storage, wait for child, placeable objects. There we go. So in our prepare preview model, we're going to send the model of just placeable objects, get children, 1. So it's just going to be the first model. Actually, we can do placeable objects dot table just for now. So dot table. There we go. So for now, we're just going to send the table. So the only thing the player will be able to place is the table. In the future, we'll edit this. So like we'll actually be able to add other parts and stuff. But this should be good for now. And then also we need to call this initiate render preview in the new function. So it will initiate render preview. It'll create the table. And I get it. This is a layer of misdirection, but we'll have another function here in a bit, which will make more sense. And this will create the thing. Also, it's box outline. I don't know how I forgot that. Okay. So now we have the part like ready to go, but we need to actually move it to where the player is looking at. So we're going to create another function for that. So we're going to say function client placer render preview. There we go. So this will be responsible. This will run every frame, and it'll be responsible for actually rendering the preview. So we need to get the mouse position. And for that, I'm going to create a separate local function because I'm going to make this local kind of outside the scope of the client placer because it's going to be a pure function. It's going to take some input, return some output, not really depend on anything. So we're going to say local function cast mouse. And this will take in nothing. And we're going to need, for this function, we're going to need user input service. So local user input service equals game get service user input service. And then we're also going to need a camera. So we're going to say local camera equals workspace dot current camera. So since we're in a local script, the workspace dot current camera will just give you like the local camera of the player. That's all you need here. So in the cast mouse, we're actually going to say local mouse location will be equal to user input service get mouse location. So this will return the XY position on the screen of the user's mouse. And we need to convert that into 3D space. Luckily, the camera has us covered. So we're going to say local ray equals camera viewport point to ray. And this will take in the mouse location dot x and the mouse location dot y. It's kind of tacky syntax, but oh well. We have to split up the vector2 into its components because this viewport point array takes a viewport point, which is just our mouse position in this case, and then it converts it into a ray positioned at the camera pointing towards where the actual point is pointing. So this should do us right. And all we need to do now is just return a raycast because it's called cast mouse. So I'm going to say workspace.raycast or workspace colon raycast ray.origin. So this will be like where the camera is. And then we're going to do ray.direction, which this is a unit vector. So we need to multiply this by some large number. I'm going to say 1,000. So the player can only place blocks 1,000 blocks away. Obviously, in the future, we're gonna make some placement validators to make sure the player can't place outside of their plot. But for now, for rendering purposes, we don't really care. This is local. No one really cares. The server will validate all the stuff in due time. So that's our cast mouse done. Now in the render preview, you can say local cast equals cast mouse. And then we can say if cast and cast dot position. So we're basically saying if the cast is successful, so we actually hit an object and we get the position from that, say local CF, which is shorthand for C frame. We're going to do C frame dot new cast dot position. So for now, we're only caring about the position. In the future, we'll add rotation and we'll clamp the position, or we won't clamp it. We'll verify the position is like within bounds. But all we need to do now is just say self dot preview pivot to CF. And remember how we changed the pivot to the bottom of the part? This will actually move the pivot to that position. So when you actually, like in the past, you would cast a mouse and then you have to offset it by some Y value. No more do you have to do that because of pivots. The mouse will hit the floor, but the floor is the pivot, so it'll look fine. And you'll see that in a second. So this is all the scaffolding done. Now in our initiate render preview, we first prepare the preview model, and then we're going to actually bind a run service event. So at the top, I'm going to say local run service equals game get service run service. So we're going to bind to render step. So we're going to say run service bind to render step, and we're going to take a name, which is a string. So for this, I'm going to actually define a constant at the top of the file called local preview render, which will be equal to preview render, or render preview, I guess. Doesn't really matter because we're just going to have to use a constant to unbind it later. So we're going to say bind to render step, preview render. You don't want to use a normal string here because you don't want to mistype it later. You want your interpreter or your compiler or whatever to tell you that is wrong. That's why we're using that constant. And then we need a priority. This honestly like doesn't matter for our case. I'm just going to do enum.render priority dot camera dot value. So this is just an integer to tell you when to like actually render it. Doesn't really matter for our case. I just choose a camera, I guess. And then we need a send it a function, which will take in a bunch of arguments. We don't really care what they are. It'll call self render preview and it'll send in those arguments. We don't really care what they are, and it'll finish. And that's it. So I know the syntax is kind of tacky. No way to get around it. Oh well. And also, you may notice that our render preview actually doesn't take any arguments. But bind to render step does give you like a delta time or whatever. So in case you ever wanted to use that, you could plug those in here. But we don't really care. We're just doing this as a good practice because this is just forwarding all of the arguments and stuff to the render preview. But we need to use this self thing to get the colon because it's aware of itself because we're setting self.preview down here, or we're like messing with it. So yeah, that is our render loop kind of done. And all we really need to do now is, well, I guess first, let's test this out. So this should work very nicely. So we're going to press B to enable build mode, and you can see our part is here. But you'll notice if I press B again, it's still here. Nothing gets cleaned up. That's what our destroy method's for. So let's go in our client place to destroy. First things first, we need to get rid of our preview. So if self.preview, then self.preview destroy, because this is a model, and then we're going to say run service unbind from render step, and we're going to send in the preview render that we made before. This is why we make it a constant, because we use it in two places, because we bind it and then we unbind it down here. So this should prevent our script from actually running when we stop our build tool. So now when you like toggle your build on and off, you should get it, it's on, and it turns off. You get it, it's on, turns off. Cool. That's exactly what we want. But right now you can only just see the block. You actually need to, place the block. So to do that, we're going to go back into our client placer and define yet another function. Call this function client placer try place block. So the reason it's called try place block is because we're on the client. We don't really know if the server is gonna like let us place it. So it's called try, just to let everyone know, like, hey, like this may not be successful. You may not be able to place the block if it's outside of your plot or if it's in intersecting another part. Like you don't want to do that. So that's why we name it that way. Right now in our current state, we won't actually test for that stuff. So every block place should be successful, but whatever. It's just like we'll get there down the line. So this is another context action service bind. That's why we have the underscore state underscore. So we're going to say if not, or I'm going to say if input state or if state is not equal to enum.userinputstate.begin, then return. This is just a little early abort. And then otherwise, we're going to say local success equals the invocation to the server, which we actually haven't defined yet. So let's work on that. So in replicated storage, we're going to create a new remote function. And the reason it's going to be a remote function is because we're going to return a Boolean true or false to determine like whether or not the placement was successful. So we're going to call this try place. And then in the client, we need to actually get that. So we're going to say up here, local try place equals replicated storage. Actually, let's keep it consistent. Try place equals replicated storage. Wait for child. Try place. There we go. Okay. So we have try place in place. No pun intended. Now we need to say local success equals try place invoke server, and we're gonna send it the self.preview.name and then self.preview get pivot. So we're sending the name because in the future we're going to add multiple object support. So we have multiple object support, and then so we need to tell it like which object we actually want to place, and then we're going to send the pivot, which is the C frame of where we actually want to place it. And that's really all we need. So in my tutorial series, you're not actually going to do anything with this success value. But if you're actually making this into a game, I would hook this up to like a GUI event where like you can pop up little notifications that says unable to place block, like please try again or whatever, just to let the player know like, hey, like you weren't allowed to place it. But for us, like we don't really care. This is a tutorial. But yeah, just a little FYI. But this try place block is never actually going to get run. So we have to run it. And for that, we are going to, first of all, get the context action service. Say local context action service equals game get service context action service. There we go. And then in our new method, we're going to say context action service bind action. And then again, we want to define our name up here because we're going to need to unbind it later. So we're going to say local place action is going to be equal to place. And then we're going to bind the action, the place action. And then the function is going to be a function taking in the inputs, and the little ellipses means that like the variadic argument. So it takes all of the arguments, and then we're going to just say self try place block with all of those arguments again, end it, and then we're not going to create a touch button. We're going to say false. I'm going to make this bind to right or left clicking, which is going to be enum.user input state dot mouse. Wait, no, enum.user input type dot mouse button 1. Okay. So when the user clicks mouse button 1, I know it's weird, it's not key code, but whatever. It's just mouse button 1. They will place the block. Again, this line of code is ugly because of this function block. Oh well, what can I do? You can split up multiple lines if you want. I think it's fine. It's fine here. It'll all be okay. But obviously right now, if we were to run this, we wouldn't actually get anything. So we need to go to the server and then plot manager actually more specifically, and we need to make a function and call this plot manager dot place. And this will take in the player, which is of type player, name, which is of type string, and target CF, which is a C frame. I'm being kind of inconsistent with my types here. You can go behind and be more consistent than me, but I'm just using them where it's convenient. I'm not being very strict about it, so take that as you wish. You could add types, you can not use our types. Up to you. Doesn't really matter. I just like autocomplete, so that's why I'm using it. But we take the player, the name, the string, or player, the name, the position, basically, and we need to first try to get the object. So we need to get, first of all, we're gonna get replicated storage. Actually, replicated storage. This game get service replicated storage, and then we're gonna say local placeable placeable objects equals replicate storage dot placeable objects. And we're gonna say local object equals placeable objects find first child, find first child name. So the client is sending us something. We don't know if it's legit. Some exploiter could just send some random junk and it may not be right. So we have to use find first child to say, hey, like this may or may not exist. Like if it does exist, it'll return it. Great. Otherwise, it'll just return nil. And then we also need to get the plot. So we're gonna say local plot equals plots player dot user ID. So in here, we need to check if not object or not plot, then return false. So basically, if the user sends us some junk, we want to return false, say, hey, like this is not successful. You're trying to like scam me because the server is kind of dumb and it needs to defend itself. That's what we're doing here. But if everything goes to plan, then we can say local new object will be equal to object clone. And then we can say new object pivot to the target CF. And then we can finally say new object dot parent equals plot dot object. So remember that the plot is a model and it has a folder called objects. So we have plot dot objects and that'll parent it so it actually appears. And we're going to return true because it's successful. So we have our layer of defense and then we have our actual placement logic. Again, we'll edit this later to count for out of bounds and intersections and yada yada. But right now, this should work. But before we run this, we need to first actually hook it up. So in the server, I'm going to say local try place equals replicate storage dot try place. And we're going to say try place dot on server invoke equals plot manager dot place. Okay, so let's don't mind this. I was doing something. Shh, you didn't see that. Okay, let's play this. And then we have our part. We click. We place it. The table places. Yippee. So we place it. And then you can place it out of bounds. Oh well. Also, notice, very important. Even if we turn off build mode, you can still place. We have to go into our destroy method and kill it. We have to kill the bounded action. We're already destroying the preview. That's good. But we need to kill the place action. So we're going to say contact action service unbind action place. So when we turn off build mode, we are no longer able to place stuff. That's going to be a common theme. We need to always prioritize our destroy loop because we can't leave loose ends. Okay, cool. Everything works. But you can kind of place stuff everywhere. It doesn't check anything. But that is an issue for next video. So I hope you enjoyed this video. It's kind of exciting, we actually do some placement. Make sure to check out my other placement series just for like another take on this kind of idea because this is like one way to do it and there's like another like Minecraft style way that I did a couple videos ago. So check that out if you're interested. Make sure to like and subscribe if you enjoyed this video. But with that, I hope you have a nice day and goodbye.